I'm going to start off with the solving triangles homework. Since I copy and pasted it from the textbook, you have to do 13, 14, and 15. And for these ones, it asks you to find the missing 3 measures. So for each problem, it's different, but we need to find the 3 things that aren't given to us. So let's start with 13. I've got triangle ABC. So first things first, draw your picture, label. Okay, and they tell me that little b is 25. The measure of angle B is 45. And the measure of angle C is 60. So the things that I need to find are I need to find angle A, I need to find side A, and I need to find side B, or side C, sorry. Well, angle A is easy because since you know the other ones, it's just going to be 180 minus 60 minus 45. So A, oops. A is going to equal 180 minus 60 minus 45. And that's going to give you 75. So A is 75 degrees. Alright. Next we need to find the side measures. Since we know all of the angles, you're kind of forced to use the law of sines, alright? Remember law of cosines, you need 2 sides in the included angle. Since I only know one side, I have to use the law of sines. So, let's find little c first. So, to find little c, that's going to be the sine of c over c will equal the sine of b over b. Then we can cross multiply. Divide both sides by the sine of 45. And then this is just what we're going to put into our calculator, which I'll do right now. Divided by sine 45. And I don't know if it told me to round or not, but I will. So C is going to be about 30.6. Alrighty, and then A, you have some choices. You could use the law of cosines if you wanted to, because now you do know 2 sides in the included angle. But to me, the law of sines is easier, so I'm just going to do it that way. So for A, that's going to be the sine of 75 over A. And then you can use B or C for the other side. I personally think it would be better to use B, just because B was given to us, so we don't have to worry about if we rounded wrong for C. So this will be the sine of 45 over 25. Again, we can cross multiply. Trying to write really tiny here. Divide by the sine of 45. So A, little a, is going to be 25 times the sine of 75 divided by the sine of 45. So we get that A is about 34.2. Alrighty, so now I know everything about this triangle. I found all 3 missing measures. So now I'm going to erase. 14. Triangle ABC. They tell me that little a is 8. Measure of angle B is 35. And the measure of angle C is 55. So this is very similar to the last problem. So I need to find big A, little b, and little c. Big A is easy to find because big A is just going to be 180 minus 35 minus 55. That's going to be 9, whoops. That's just 90. Alright, so it's kind of cool. I've got a right triangle, so this is 90 degrees. So now I need to find little b and little c. I am going to use the law of sines. So first I'll find b first. Doesn't really matter. So the sine of b over b is going to equal, now you can use, you can only use c in this case. I'm sorry, you can only use a in this case. So this is going to be the sine of a, which is 90, over a, which is 8. And the sine of 90 is nice because we know from the unit circle that that is just 1. Cross multiply. So I actually don't even have to divide anything. I just need to do 8 times the sine of 35. And I get about 4.6. Cool. And then last but not least, I need to find little c. So to find little c, again, you could use the law of cosines if you wanted to, since we now know b, but the law of sines is easier. So the sine of c over c is going to equal, and then I'm going to use a again just because it was easy. Sine of 90 is easy. It doesn't rely on rounding from the previous one. So that's going to be the sine of 90 over 8. And again, sine of 90 is 1. So this is really sine of 55 over c is equal to 1/8. So 8 times the sine of 55 is equal to c. Oops. Pop that in your calculator and you get about 6.6 for C. Alright, so exactly the same thing as the last problem. And looking at 15, I can see that that's different because 15 gives me 2 sides and 1 angle. There we go. 15. And it also gives me different letters, D, E, F. Little d, little f, tells me that little d is 72, big triangle. Little e is 48. And the measure of angle F is 110. So obviously this picture is not drawn to scale. So looking at this is not like the other two problems, right? I can't just do 180 minus some stuff to find my other angle. In this case, I have 2 sides in the included angle. So here I have to use the law of cosines to figure out side F. I don't really have a choice. So this is going to be little f squared is equal to d squared plus e squared minus 2de cosine f. And if you didn't want to write that, it's fine. You could have just written this step where you plug in 72 squared plus 48 squared. So, and we're going to be working with some big stuff. So f squared is equal to 5,184. 48 squared is 2,304. 2 times 72 times 48 is 6,912, and that's times the cosine of 110. I cannot write today. Oops. And then you can't combine the thing with the cosine 110, but you can combine the 5,184 and the 2,304. And you get 7,488 minus 6,912 times the cosine of 110. That is what I'm going to put in my calculator. And you end up getting about 9,852, but I need the square root of that. And I get that f is about 99. Since my other things are to the nearest whole number, that's what I'll do for the book. So f is about 99. Okay. Now I need to find d and e. Again, d and e, you can't just subtract from 180. You got to do some work, and we have options here. Now that I know all of my sides, I could use the law of cosines or I could use the law of sines. Law of sines is easier though, in my opinion. Alright, so we just need to pick one and solve for that because now I can at least use the sine of f and f because those go together. So I'll find E first. So the sine of f over f is going to equal the sine of E over E. And then I can cross multiply. Divide both sides by 99. Now when you put this into your calculator, you're not finding E yet, you're finding sine E. So then we need to do inverse sine of both sides. And we get about 27 degrees. So E is 27 degrees. And now you could do the law of sines again to find angle D, or now that we know two angles, we know that D is just going to be 180 minus the 110 for F minus the 27 for E. And that is going to give me 43 degrees. Whew, that is a lot of work. Okay, now that we're done with the book work, let's move on. You had to do 6 and 7 from the vector worksheet and 1 from the dispersion worksheet. I'm going to do the dispersion worksheet next because that was just putting stuff into your calculator. Alright, so for number 1, they gave us this table, and they gave us our data point, and they gave us our frequencies. And they gave us 78, 80, 81, 82, and 83. And then my frequencies were 1, 4, 2, 3, and 2. So this is what you should have put into your lists in your calculator. This should have been your L1, and this should have been your L2. Okay, and after you put those in your lists, remember, you go back to stat, you go over to calc, and you pick choice 1 for one variable statistics. And after you do that, you need to do L1, which remember is the second and then 1 button. You need to put in the comma, which is right above, I think, 7, and then you need to put in L2. You need to tell it to look at list 1 and list 2 because you have the frequencies in list 2. And then after you do that, you can just use what it spits out at you to answer all of these. So for part A, the sample standard deviation is 1.477. The population standard deviation has the little sigma, and that is 1.414. The sample variance, you're just taking your sample standard deviation and squaring it, and you get 2.2. For your population variance, you're just taking your population standard deviation and squaring that. And when you round appropriately, you actually get 2.0. E is the mean. Remember, mean is the X with the bar on top of it. That's 81. F, your first quartile, you're going to have to arrow down, and you will get 80. That's what says Q1. G, your median, says MED next to it, and that would be 81. Third quartile is what says Q3, that's 82. And last but not least, interquartile range. Remember, that's the difference between the third quartile and the first quartile. So 82 minus 80, which is 2. All right, that one is easy peasy. And then last but certainly not least, we need to do our vector problems. We have to do 6 and 7, which is really just more triangle problems. So, reading number 6, it says, the measure of the angles between the resultant and 2 applied forces are 60 and 45, and the magnitude of the resultant is 27. Find the magnitude of each applied force. So there are actually 2 things that we need to find. So I'll draw my picture. There are my 2 applied forces, and I know that this is going to make a parallelogram. And here is my resultant. Okay, it says that my resultant is 27, and that the angles between the two applied forces are 60 and 45. It doesn't matter which one you make 60 and which one you make 45. It really doesn't. And then I want to find both forces. So I'll call this one X and this one Y. It does not really matter. You might have labeled it differently. So let's just fill in what I know. Alright, so besides this, I know that the opposite sides are also going to be X and Y. And then we've been talking about properties of parallelograms a lot. Okay, alternate interior angles. So since this angle down here is a 45, the alternate interior angle is also going to be 45. And the same thing with 60. Since this one is 60, this one over here on the right is also going to be 60. Okay? And then, well, if you look, I've got some triangles. That's the cool thing about parallelograms. They make triangles. Alright, triangles at angles add up to 180, so I can figure out that big angle. Do I know if I need it? I don't know, but why not? And you get 75. Whew. Okay, so looking here, we actually have options, okay, because I could use the law of cosines to find one of these, but I can also use the law of sines. Alright, for instance, let's say I want to find x using the law of cosines. Alright, I'll show it both ways, but if I want to do the law of cosines to find x, you could also use it to find y. That is going to give me, let's see, can I use the law of cosines to find that? I can't. Hold on. Alright, yeah, no, I lied. I can't use the law of cosines. Whew. Got a little ahead of myself there. So I gotta use the law of sines. So looking at this, I can find x or I can find y first. I'll do x. So looking at x, that is going to be the sine of 45. I don't know why my board is doing that. Over x, because 45 is across from x, and that's going to be equal to the sine of 75 all over 27. Cross multiply, 27 times the sine of 45 is going to equal x times the sine of 75. Full screen here. Divide both sides by the sine of 75. Pop that into your calculator. 27 times the sine of 45 divided by the sine of 75. That is going to be 19.8. If I'm rounding appropriately, I can't remember what the units were. Oh no, I'm going nearest pound, right? So that's 20. X is 20. Okay. So this is 20. And this is 20. And then I can go ahead and find y. I'm going to use the law of sines again. So that is going to be the sine of 60 over y is equal to the sine of 75 over 27. Cross multiply. Divide by the sine of 75. So 27 times the sine of 60 divided by the sine of 75. Rounding to the nearest pound, that would be 24. Alrighty. So no law of cosines, just the law of sines. Boop. And number 7, last problem. 2 tow trucks try to pull a car out of a ditch. One tow truck applies a force of 1,500. The other one applies a force of 2,000. The resultant force is 3,000. Find the angle between the two applied forces, rounding to the nearest degree. So here I have no angles, they just give me forces. So, draw my stuff. So here's, I don't know why it curved. So this is 1,500. That's 2,000. drawn by parallelogram. So this will also be 2,000. Could have swapped the measures, it doesn't matter. And then they tell me that my resultant is 3,000. And it wants me to find the angle between the two applied forces. So what it really wants me to find is this whole medium-sized angle right here. Okay, well, we can't really do that just yet. Okay, so what we're actually going to have to do is we're going to have to find these two little angles, and then we can add them up to get this medium-sized angle. Maybe. We'll see. Or we actually have another way that we could do this. What we could do is instead of doing this twice, using triangles twice, what we could do is just figure out what this big angle is, right? Because this big angle is going to be equal to this angle over here, and we can subtract those from 360 and divide by 2. That plan seems a lot better. All right, so if I look at my little triangle right here, this one is appropriate for the law of cosines because I have all of my sides and I want to find an included angle. So this is going to be through, let's switch back to our pen. So 3,000 squared is going to be equal to 1,500 squared plus 2,000 squared minus 2 is 1,500 times 2,000 times the cosine of, we'll call it x. Alright, so let's put this calculators. This is going to give me 9 and then 1, 2, 3, 4, 5, 6 zeros. 1, 2. So then I can combine these and subtract it over. So 225, 1, 2, 3, 4 zeros, plus 4, 1, 2, 3, 4, 5, 6. So this is 9. So then I'm going to subtract over. So 9, 1, 2, 3, 4, 5, 6 minus that. Extend my page. That is going to give me 2, 7, 5. And then I'm going to divide. And inverse cosine. So x is going to be about 117 degrees. So not the angle that I'm looking for, but this angle right here is going to be 117, which means that this angle over here is also going to be 117. So if I do 360 minus 117 minus 117, that is going to give me 126. So I have 126 degrees left for these two angles, so I'll divide by 2, and that is 63. So this angle right here that I was looking for is 63 degrees. If you went through this and found this little baby angle, and then found this little baby angle, and you added them together, you still would have got 63 degrees. I just didn't see the point of finding two angles when I could have just found one and then the rest was just subtraction. And that is it. I'm sorry this was so long, but these triangles involve a lot of work, and this problem involved a lot of zeros.